The nearest star to Earth is 4.2 light-years away. That sounds close. It isn't. If you drove there at highway speed, it would take 50 million years. And that's our closest neighbor. Now imagine standing on a beach at night. Across the ocean, you can see a single light glowing on the horizon. You know it's there. You know it's real. But no matter how fast you run, no matter how powerful your boat becomes, you never get any closer. Now replace that light with another star. That is humanity's greatest problem. For thousands of years, we've looked into the night sky believing the stars were destinations, places waiting to be explored, new worlds ready to be discovered. But what if they aren't? What if the universe is built in a way that makes reaching another star almost impossible? Today, we're going to confront one of the most unsettling truths in all of science. Not that aliens don't exist, not that space is empty, but that the distances between stars may be so overwhelming that civilizations are trapped forever inside their own tiny islands of light. A universe that doesn't want to be crossed. Every diagram of the solar system you've ever seen is lying to you, not because it's wrong, but because the real solar system is far too large to fit on a page. If Earth were the size of a marble, Neptune would be kilometers away. Between them, almost nothing. Mostly darkness, mostly silence, mostly empty space. And yet even Neptune isn't the true edge of our home. Far beyond the planets lies a frozen cloud of ancient ice and rock, known as the Oort cloud. A vast shell left over from the birth of the solar system. It stretches so far into the darkness that sunlight arriving there is barely distinguishable from the surrounding stars. Even reaching that boundary would take humanity thousands of years with today's fastest spacecraft. Not another galaxy, not another star, just the edge of our own backyard. And that's before we even begin to talk about the speed limit. Speed limit naturally. The first solution people imagine is simple. Go faster, much faster. For centuries, every transportation revolution has followed the same pattern. Horses became trains. Trains became airplanes. Airplanes became rockets. Surely the next step is a starship. But the universe has a rule that refuses to be broken. Nothing with mass can travel faster than the speed of light. It isn't just a technological limitation. It's woven into the fabric of reality itself. Even if humanity built engines powered by fusion or antimatter, technologies far beyond anything we can currently operate at scale, we would still face staggering travel times. Imagine a spacecraft reaching 20% of light speed. At that incredible velocity, a trip to Alpha Centauri, our nearest neighboring star system, would still take around 20 years. 20 years confined inside a machine. 20 years relying on every life support system to function perfectly. 20 years, knowing that turning back is no easier than continuing forward. For a civilization used to instant communication and overnight travel, that journey borders on unimaginable. But even if we accepted those 20 years, the universe has another problem waiting. Space isn't empty. Most people picture space as a perfect vacuum, a peaceful void, serene. In reality, it's full of danger. Individual hydrogen atoms drift between the stars. Tiny grains of dust float silently through interstellar space. Normally, these particles are harmless, but velocity changes everything. At 20% of light speed, a single hydrogen atom no longer passes through you harmlessly. It strikes like a tiny bullet, then another, then billions more. Every second of travel, the spacecraft is being peppered by the invisible fabric of the universe itself. Over months, over years, the hull is being slowly eaten alive. Surfaces erode, sensors degrade, systems begin to fail. Now imagine something slightly larger. Not a rock, not an asteroid, just a grain of dust. Something so small you could barely see it between your fingers. At relativistic speeds, that particle strikes with the energy of a small explosion. The crew has no warning, no time to react, no chance to change course. At the velocities needed to reach another star, the universe stops being an empty road and becomes a wall of invisible shrapnel. The faster you go, the more lethal existence becomes. And that's before we even consider what might be waiting on the other side. The cruel reward. Let's imagine humanity solves every challenge. We build the engines, develop advanced shielding, protect ourselves from radiation, keep a crew alive for decades, against all odds. We finally arrive. What are we expecting to find? Blue oceans, green forests, a second Earth. Reality is far less generous. Most nearby stars are small red dwarfs. These stars live for trillions of years, but many are astonishingly violent. They unleash powerful stellar flares capable of stripping nearby planets of their atmospheres entirely. Some worlds are locked forever, one side burning in endless daylight, the other frozen in permanent night. Others lost their oceans billions of years ago. Many are nothing more than scorched, irradiated rock after 20 years of travel, after the greatest journey in human history. Humanity's first destination could be a world even less hospitable than Mars. And if every destination within reach is barren, if the nearest stars offer nothing, then we have to ask a question that has haunted scientists for decades. The technology we don't yet understand. Before we get to that question, history deserves a moment. People living thousands of years ago couldn't imagine electricity. They couldn't imagine computers. They couldn't imagine satellites orbiting Earth or robots exploring Mars. To them, those ideas would have seemed indistinguishable from magic. Perhaps we're in the same position today. Our rockets may be the equivalent of wooden rafts trying to cross an entire ocean. Future generations may discover entirely new ways of moving through space. Warp drives, exotic space-time engineering, physics that remains hidden because our science is still in its infancy. These ideas aren't impossible. We simply don't know yet. But here's the uncomfortable truth. Every proposed shortcut still runs into the same walls. Energy requirements that dwarf anything in the observable universe. Materials that don't exist and may never exist. Physics that requires bending laws we've never seen bent. Maybe those barriers fall one day. Maybe they don't. But here's what makes the question truly terrifying. We're not the only ones who would have asked it. Where is everybody? If the universe is filled with billions of stars, if planets are common, if life can emerge given enough time, then where are they? Where are all the civilizations that should have come before us? Every civilization capable of asking this question eventually reaches the same conclusion. The stars are visible, but they're separated by distances so vast they become practically unreachable. Think about what that means. Somewhere out there, maybe thousands of light years away, another species looked up at their night sky. They saw the same stars we see. They built their telescopes. They asked their own questions. They dreamed about crossing the void. And then they hit the same wall, the same physics, the same distances, the same silence. Every civilization that has ever existed may have reached this exact moment and found no way through, not because they failed, not because they gave up, but because the universe may have been designed, if you can call it that, to keep minds separated forever, each one a tiny flame, burning alone, unable to signal across the dark, including us. That is the loneliest thought in science. Closing every night, thousands of stars appear above our heads. Each one is another sun. Many have planets. Some may even have life. They're close enough to see, yet impossibly far away to touch. For now, humanity remains a young civilization standing on the shore of an infinite cosmic ocean. We dream about crossing it. We build better ships. We invent better engines, and we continue looking toward lights that may never be reached. But maybe that's not the right way to end this, because the question was never really about whether we can reach the stars. The question is whether anything can. and the universe so far hasn't answered. The stars aren't waiting for us. They never were. They're just burning, indifferent to whether anyone ever arrives.